Good day, third graders. All right. Today's lesson is called Angles, Triangles, and Other Polygons. Again, we are in Unit 7, and this is Lessons 5, a little bit continued, and 6. I know we didn't do a lot with triangles yesterday, but we're going to do a little bit more with polygons, which triangles are a part of. So let's look first at yesterday's math journal question. If Mrs. Jones leaves home at 6:45 and arrives at school at 7:21, how long did it take her to get there? Okay, this question asks for elapsed time. Remember, we're going to answer in our label is going to be minutes. So I counted on from 6:45 until 7 o'clock, and I got 15 minutes. And then from 7 to 7:21 is 21. And then I added 15 plus 21. Make sure you show your work or have an equation that explains what you are thinking. And do today's math journal too, third graders. All right. We are going to open our math books to page 460. We're going to talk about polygons today. The polygon is a flat, closed figure made up of line segments that do not cross each other. Okay. Poly means many. Gon refers to angles. So polygon means many angles. There are two terms to learn, concave and convex. You can see from the picture here, concave, I think of going into a cave, and convex is the opposite, not going into the figure, like the examples show. So let's talk. Can you measure a line segment, third graders? You can, right? Because it has an endpoint. It starts at one endpoint and goes to another. How about a line? Can you measure a line? No, because a line goes on in both directions and there's no start or stop. So when you are making polygons, you are using line segments, not lines. All right, let's circle, third graders, the figures that are polygons. Look at number 18. Is that a polygon? How do you know? Well, it has straight line segments. All of the line segments are connected. So it's closed, and the sides don't cross over each other. So yes, it's a polygon. Let's look at number 19. Number 19. The sides are straight. They are connected, but they do cross over each other. So number 19 is not a polygon. Don't circle that one. Okay? Go ahead and pause the video if you need to circle the polygons that you see. Then third graders, you need to label which figures are convex and which ones are concave. Remember, concave goes into the figure. So if it has any endpoints that are in the figure, you are going to list them as concave. All right. We're going to look at page 461, and then I'm going to show you the answers for both of these pages. So on 461, these are polygons that you need to know. All right, they are named according to how many sides and vertices. There's that vertex in plural, vertices they have. So just a really quick chart here of triangle, quadrilateral, pentagon, hexagon, octagon, and decagon, according to the sides and the vertices. Polygons to know. So third graders, you are going to pause the video so that you can look at each of the polygons, list the number of sides, the number of vertices, and also to name it. Make sure you finish page 460 and 461 because I'm going to share the answers with you in just a second. Pause the video. All right, so third graders, you can pause the video again so that you can check your work. We circled polygons, we named convex and concave figures, and we also looked at common figures of polygons and listed how many sides and vertices and named them. Stop the video if you need to check your work. All right, we're going to keep going and we're going to jump into lesson 6 right now. And we are going to describe parallelograms. So let's define a parallelogram. All of these figures in the bluish, turquoise-ish color there are parallelograms. Both pairs of the opposite sides are parallel. But the purple figures are not parallelograms. You might see some opposite sides parallel, but what makes it a parallelogram if it has only two pairs of opposite sides? That's why J, for instance, is not a parallelogram, or G. The opposite sides are parallel for one pair, but not for the other. So write your definition. A parallelogram is a quadrilateral with opposite sides that are parallel. The opposite sides have to be the same length. If you have a ruler, third graders, measure these parallelograms and look and see what patterns you notice about them. You're going to label with the nearest centimeter their lengths. What did you notice? Each figure, the opposite sides are the same length. When you measured, the opposite sides are the same length. That's what they have in common. All right, third graders, go on to page 464. We're going to describe rectangles. There are 4 rectangles here. You might say, that looks like a square, Mrs. Martin. But all of those are rectangles. Rectangles have adjacent sides that are perpendicular. Remember, adjacent means they meet at a corner, okay? And Adel says rectangles are special kinds of parallelograms. Is he right? What do you think? Yes, he is right. Rectangles are special kinds of parallelograms. They're special because they have 4 right angles. So make sure that you finish this definition. A rectangle is a parallelogram with 4 right angles, or you could say 4 90-degree angles, or 4 square corners. The other 2 words we're going to focus on are square and rhombus. So let's explore squares and rhombuses. The yellow figures are squares. The green figures are rhombuses. Takashi said, squares are special kinds of rectangles. Are squares rectangles? Yes, they are, because they're parallelograms and they have right angles. Their sides are all the same length, though. That's what makes them special. Cora says rhombuses are special kinds of parallelograms. Are rhombuses parallelograms? They are. They don't have right angles or square corners, but their sides are all the same length. Okay? Now, can they have right angles? Yes. So is a square a rhombus? Yes. All these defining things for us to do, third graders. All right. That's all I have for you today. We'll check in more later. Don't forget to do your journal. Have a great day, third graders.